Now welcome to our next class. Today we discuss about the diesel cycle. Last stage we try to learn about the Otto cycle. Now today we discuss about the diesel cycle. From the name you see that there is a word diesel. That means the cycle helps the mobility of engine where the diesel is act as a fuel. That means it apply for heavy vehicle for running purpose. Now diesel cycle. Previously, Otto cycle, we said that it is a spark ignition engine, and today we know that it is a CI engine. Both the SI engine and CI engine is nothing but part of IC engine. That means internal combustion engine. Internal combustion means the combustion is happened inside a closed chamber, where there is a piston, there is a flywheel. There is a crankshaft is there, which the up and down of the piston, that means it's whenever go from the bottom dead center to top dead center, the crankshaft is rotate, and by this rotation the piston moves, and by the moving of this, the compression or the expansion happened and the burning process is happened. And what is the difference with the SI engine? In this engine, there is no sparking is happened. As the system is large, more than the large than Otto cycle, what happened here? Here, due to the compression, the temperature and the pressure is rise so much that whenever you throw the fuel inside the chamber, this is burned automatically. That is combustion start. Now, from the previous study, we know that this cycle is represented with two graphs. One is PV diagram and one is TS diagram. Then one is pressure volume diagram and one is temperature entropy diagram. This P, this P. And another one is as T. Now we draw this cycle. You see that in our Otto cycle there is two constant volume process, but you see that here there is one constant volume process and one constant pressure process. That means heat is added here at constant pressure, whereas you see that the heat is rejected here at constant volume. And other two process, that means 1, 2 and 3, 4 are similar like Otto cycle. That means it is a reversible adiabatic process. You see that when the heat is added, here the volume is little bit increased. So we can write first for process 1, 2 there is must be compression ratio, and compression ratio is here is nothing but V1 by V2. That means the volume at the start of the compression process by the volume at the end of the compression process. End of the compression process. Another is expansion ratio, which is denoted by expansion, the volume at the end of the expression by volume at the start of the expansion, V4 by V3. Another thing is cut-off ratio, that means at the start of the combustion and at the end of the combustion and the start of the combustion, which is known as the cut-off ratio, which is nothing but V3 by V2. This compression ratio is denoted by RK, expansion ratio is denoted by RE, and cut-off ratio is denoted by RC. Now, we try to look after what is the relation between that. It is looks like that RK is equal to RE and RC. I said that, but is it correct or not? Look that if we write like that, then we can write RE is nothing but V4 by V3 and it is RC is V3 by V2. Then V3 is cancelled. Now this equation looks like V4 by V2. From the graph we see that V4 is equal to V1. Then we can write V1 by V2. That means it is RK. That means whatever we write about this expression, it is correct. Not only said that, it is proved. Now, for as per previous time or previous cycle, that means auto cycle, we have to must known about the efficiency of the diesel cycle. What will be this? It's 1 minus Q2 by Q1. Now 1 minus what is Q2 for this diesel cycle? Sorry, first this heat addition at constant volume, constant pressure. What is that? This is M into Cp. Look, then T3 minus T2 and Q2 must be M. It is happened constant volume heat rejection. That means Cv. It is T4 minus T1. Now, what will be our efficiency? It is M Cv T4 minus T1. Now M Cp T3 minus T2. Now we can write 1 minus T4 minus T1 into T3 minus T2 into Cp by Cv. Then what will looks like 1 minus T4 minus T1 by, we know Cp by Cv, it is nothing but gamma T3 minus T2. This will be expression for efficiency of diesel cycle with the, this is the derivation of efficiency of diesel cycle. Now we have to convert this thing with different ratio. That means it may be expansion ratio, it may be compression ratio, but we go for that, or it